This is our R mini project group. Saurav Ahuja 82, Avinash 83, Janam Doshi 84. Project topic is to predict the satisfaction of passengers traveling through a particular airline. The motivation behind selecting this topic was there is a cutthroat competition between different airlines and different factors come into play, such as seat comfort, online boarding, in-flight Wi-Fi service, in-flight entertainment. So we wanted to select this topic. Our detailed problem statement is going to be explained by Saurav Ahuja.
So in this project, we are going to implement exploratory data analysis to get an insight of the data, and to predict the satisfaction of the customer, we are going to use logistic regression. First of all, we load the CSV file, and as we can see, the dimension is 1 lakh rows and 25 columns. Now we see the structure of the data. It consists of serial number, ID, gender. Customer type has been divided into two types, that is loyal and disloyal customer. The type of travel has been divided into two classes, that is personal travel and business travel. The classes are divided into three types, that is eco plus and business. And the rest of the data has been presented in the form of 0 to 5 as ratings. Now we get a glimpse of the data by using head command, and now we perform the EDA over the data, and to perform it we install multiple packages. Now first we convert all the values in the data set to title case and remove the extra spaces that are present between the data, and we get a glimpse of the data that is as follows. Now we convert all the values to yes and no in the satisfied column. Then we replace all the values present in arrival detail value, which are missing values, by the mean of it. Then we calculate the probability of loyal and disloyal customers, and we perform multiple operations over it, such as mean, distinct values table for counting satisfied and unsatisfied customers, and the probability of it. Now, as we can see, we are counting the classes, counting the number of classes such as business, eco, and eco plus. Now, according to the type of travel, we are finding out whether the customer is satisfied and the count of it. In this, we are going to count the number of passengers satisfied or not based on the classes in which they travel. In this, we are going to count the number of passengers satisfied or not based on the type of customers such as loyal and disloyal customers. Now, the dataset is first grouped by gender and type of travel column, and count the number of passengers based on their gender and type of travel. In this, we are going to group the dataset according to the gate location, and we are going to find out whether it is satisfied or not, and the respective count. Now we are going to perform data visualization, and to perform it, we are going to install multiple packages for it. So now we are going to begin with a univariate graph. In this, we are first of all going to see pie plot. In the below graph, we can it shows the proportion of men to women from a set of passengers. So the insight we get from this graph is there are more number of female passengers compared to men. In the second pie plot, we are going to show the proportion of passengers in each class, and the insight that we get from this pie chart is there are more number of passengers traveling in the business class compared to eco and eco plus. Now we are going to see the histogram plot for the flight distance distribution. So as we can see, as the distance increases, there are less number of passengers willing to travel, and as we can see, there the mean is 1,200 kilometers.
Yeah, so the next graph is the 3D pie chart for the satisfaction count. The insight that we get from this graph is that the total number of passengers which are satisfied and which are not satisfied. So 40% of them are satisfied, whereas 56% of them are not satisfied. And the bar plot graph based on the type of customers. From this graph, we get the insight that there are 80,000 of the customers are loyal, whereas the 20,000 of the customers are disloyal. The next type of the graph is the bivariate graph, the bar plot graph based on the satisfaction by the seat comfort and the class. So the ratings that we get, the seat comfort for the economic class is the poor, and that of the economic class is good, and that of the business class is very good. The bar graph of online boarding was his satisfaction. So from this graph, we get the insight that there are variation of the ratings from 1 to 5 for the online boarding. Next is the histogram plot of number of gates versus the number of gates versus the number of passengers. From this graph, we get the insight that there are the traffic of the passengers at each and every gate, and the number of traffic of the passengers at gate number 3 is the highest. The next graph shows the distribution of the customers based on the type, loyal and disloyal. From this graph, we conclude that the economic class is the least disloyal customer as compared to that of the business and economic class. The next graph is the scatter plot of the flight distance versus the departure delay. As the flight distance increases, goes above the 200. You can see that the departure delay also goes above the 600 minutes. Then the next graph is the line graph, which shows that when the flight distance goes beyond the 200, the arrival delay in minutes may touches up to 4 hours. And the next graph is the density plot of customer satisfaction with the service based on the class type, which is business class, economy class, and the economy plus class. The next graph is the box plot based on the flight service and the type of class. So in this, there are the quartile 3 is not present in the economic and economy plus class, which shows that the passengers have not rated them. And there are also outliers present in the economy and economy plus class. The line in the middle shows the median of the value. The next graph shows the relationship between the arrival delay in minutes and the flight distance. As the flight distance increases, the arrival delay also increases.
Talking about logistic regression model, we have imported CA tools library and we are splitting our sample into the ratio 80-20. 80% data is going to be used for training and 20% for testing. And we have divided the data in such a way, as you can see, the probabilities are very close. Now we start training our model and it helps us to get the intercept and the estimate for all the columns, which will help us to calculate the probability of our customer being satisfied or not. So now we give the model our test data and we print the first 10 probabilities. As you can see here, what we are going to do right now is we are going to follow the principle of logistic regression. All the values above the 0.5 will be turned to 1 and rest are going to remain 0. Now we are printing a confusion matrix. The order is as follows: true positives, false negatives, and true negatives. As you can see, we have calculated the accuracy of our model manually using this value, and the accuracy turns out to be 87.5%. We tried to create another logistic model, taking selective columns that we think can have a greater impact on the satisfaction of passengers. These columns are arrival delay, departure delay, flight service, flight distance. So we are going to perform the logistic regression on this. We are again going to divide our data into the 80 and 20% ratio. And as you can see, again, probabilities are very close here, differing in decimals after 0.7. This is a summary that we get mean, median, and all values. We are going to train our model. After that, we print the summary of our training model. As you can see, again, we are getting the intercept and all the values of different columns, which can help us to calculate the probability. We are going to pass on our testing data set and we are printing the first 10 probabilities. The similar procedure for all values greater than 0.5 to be turned as 1. Now, this is the formula that was being used by a system to calculate the probability. I'll show one example manually. I've considered the age to be 21, arrival delay as 5 minutes, departure delay as 2 minutes, flight distance as 200 kilometers, and the flight service to have a rating of 3. So these were the factors that were highly positive, and as you can see, the probability turns out to be 0.82. Again, I print my confusion matrix, but the accuracy is actually reducing when I am taking just certain factors into account. So assumption was wrong that few columns might have a greater impact, but we can conclude now that all the columns contribute to the satisfaction equally. Further part is going to be explained by Jainam.
Yeah, so we have used the library R part and we have created the decision tree. So in this decision tree, we have considered the factor of the passengers who are not satisfied. So whenever the flight distance is greater than 1500, the probability that the passengers are not going to be satisfied is going to be 30%. And when they are rating the flight service greater than 4, the probability of them not getting satisfied is 20%. So this is how the entire decision tree is being formed. So below is the regression graph. In this graph, we have in order to predict the quantitative value of the y, it will be based on the predictive variable x. In the x-axis, we have used the departure delay, and in the y-axis there is a satisfaction. And you can see that the line is in the negative trend, which shows that whenever the departure delay is more, the passengers are not satisfied, and whenever the departure delay is less, the passengers are more satisfied.
We can conclude that different factors were actually coming into play that we were not expecting, such as the basic service of Wi-Fi or the food rating, which were affecting the entire satisfaction of our passengers. This is our final conclusion.